And lastly is, of course, the apex of reservoir engineer analysis is reservoir simulation. Okay, so this is the workflow. It's quite a heavy job, even for reservoir engineer. It's also multidisciplinary works, so you cannot construct your reservoir simulation alone. You need geologists and petrophysicists to construct the reservoir simulation. So you start with this data, seismic data, and well logging data. From that, you construct the structural model, and you also parallel with that prepare the facies model. And then from that, you construct the stratigraphic model. From this one is actually done by geomodeler. So it's more about geologic works rather than reservoir engineering works. Okay, so our friend geologist or geomodeler deal with this one, including this one. If you have 4D seismic data, they will also incorporate the data into our geological model. By geological model here means facies model, porosity model, and permeability model. All right, so we call this step as static modeling. Starting from this static modeling, we will continue with dynamic modeling. And dynamic modeling is the responsibility of as reservoir engineer, or maybe you can also say reservoir simulator. Okay, it has a lot of grids. Of course, you need to do upscaling. Okay, so we continue with reservoir gridding, upscaling to reduce the number of the cells so that we can get a faster calculation, upscale, and you run the history matching, you run the flow simulation, and after get the history matching, you then construct the scenario. How much well, how many wells you will drill, how many wells you will do workover, and how will you increase or decrease the production and or the injection. Okay, and that's why we call it flow simulation. We integrate a lot of data, mainly production and pressure data. And from that, we can update our geological model. So it's a circular or cyclical job. It's a multidisciplinary job. And yeah, this is the reservoir simulation. And it is very, very important. The result it gives is really crucial for our works as reservoir engineer. So we will get the porosity map, permeability map, net to gross map, and top map, and also maybe HCPV map, hydrocarbon portfolio map. That's really important. And movable oil map like this one. This is really important. This is a oil saturation map. The blue zone means that very low oil saturation. The red zone means very high oil saturation. And we have well here, and you can see in this area and in this area we don't have any well. So it means it gives us a very clear information, a very clear and good information that we actually can drill our well here, and we can also drill our well here, or maybe we can make the well spacing even tighter so we can drill another well here, right? We put that into the simulator, into the simulation, and we run the forecasting, and we will get this, the more or less the same analysis with material balance analysis regarding the reservoir pressure profile, the water cut profile, the production profile, and so on and so forth. All right, so this is really important, but actually it's not that easy. It's not that straightforward. Most of the time, reservoir simulation is very tedious, okay, time consuming, and sometimes it gives us not really reliable result, which maybe makes us go back to material balance analysis. If the result is very unreliable, And if the model itself is very complicated, we usually go back to material balance analysis. All right. So yeah, those are 10 analysis we do as reservoir engineer. So as a concluding remarks, as reservoir engineer, we do a lot of analysis, material balance analysis, rate and pressure transient analysis, production data analysis, nodal analysis, fluid contact analysis, water encroachment analysis, formation evaluation, and reservoir simulation. Okay, the main thing, the main objective is reserve evaluation, how much oil we still have inside the reservoir, and production forecasting. So those are the two keywords for you if you want to continue as reservoir engineer. Reserve and how to forecast the production, okay, for a given scenario. And yeah, this is the concluding remark. So you have data here, you have a lot of data, thousands of data or millions of data from the operation, from your reservoir. But those data will give us no added value. Okay, if we don't turn those data into information. Okay, we make that data as information and we connect each information to obtain knowledge from our reservoir or from our operation. And we notice some key observation and we get insight from that. And again, we connect each insight, we get wisdom. And lastly, it gives us impact. Maybe increase revenue, increase production, longer production period, many things from connecting the dots. All right. So we can conclude reservoir engineers utilize large amount of data to, you can see this, characterize the reservoir. And not only characterize the reservoir, but also predict its behavior and performance, production performance here, under certain operational scenarios. All right. The main objective, achieve as high recovery factor as economically operationally possible. All right. So it's another keyword, recovery factor. Achieve as high recovery factor as possible from your reservoir. All right. So I think that's all. I give back to the moderator and let's open the Q&A session. Thank you.